Hello, this movie is for Learning Target 3, Perimeter and Area Ratios. So what I want you to do in numbers 1 and 2 is take each of these, and I want you to answer those questions writing the ratio as a reduced fraction. So on number 1, you're going to be doing the scale factor, which means small figure to the large. So if I did small to large, it'd be 60 over 90. But what does that reduce to? Because I want to make sure you've reduced the fraction, and that is 2/3. So pause the movie, try completing all of these for question numbers 1 and 2, and then press play when you are finished. Okay, the ratio of the perimeters we know is 240 over 360. It's just the distance around. That reduces to 2/3. Interesting. Ratio of the areas, which is base times height, 3,600 over 8,100, reduces to 4/9. Interesting, not 2/3, but definitely related. Over here, we've got, for number 2, we've got that the perimeter of this one is 100. The area of this triangle is 300. The perimeter for this guy, which you may or may not have been able to find, was 40, and the area is 48. So I wanted you to put 10 in there. So the scale factor is going to be 14 over 35 if I'm using these two, which reduces to 2/5. The ratio of the perimeters will be 40 over 100, which reduces to 2/5. Again, similar. Ratio of the areas, 48 to 300, reduces to 4/25. So the question is, if I know for each of these examples, my scale factor, if that is A to B, what would be the ratio of the perimeters? Well, notice that these two are the same. The scale factor and the ratio of the perimeters is the same for both. But what we see is that the ratio of the areas is different. Now, what did I do to 2/3 to get 4/9? Well, I know that 2 squared is 4, 3 squared is 9, and over here, 2/5, if I square those, I get 4/25. So this is really A squared over B squared, ratio of the areas. So looking at the examples above, how does the ratio of the perimeters relate to the scale factor? They are the same. A over B. How does the ratio of the areas relate to the scale factor? Well, the ratio of the areas is A squared over B squared. You basically take the scale factor or the ratio of the perimeters and square it. Given two similar figures with the scale factor of 4 to 9, so this is their scale factor is 4 to 9. What's the ratio of the perimeters? Well, what we know is that it will be the exact same for the ratio of the perimeters. The ratio of the areas will be 4 squared over 9 squared, which is going to give you 16 over 81. Given that two similar figures have a perimeter ratio of 3 to 10, what's the ratio of the areas? Well, we've got to take 3 squared and 10 squared, and that's going to give us 9 over 100. Given that two similar figures have an area ratio of 16 over 36, the ratio of the perimeters. So this is the squared. What we need to do to figure out the perimeters is square root. That's going to give us 4/6, which could be written as 2/3. Given that two similar figures have a scale factor of 3 to 5, find the area of the smaller one if the area of the larger one is 300. So I know that the ratio of the areas will be 3 squared to 5 squared. So the ratio of the areas is 9 to 25. So what I'm going to do is set 9 to 25 as my ratio of the areas equal to, now it says the area of the smaller one to the area of the larger one is 300 feet. If the area of the larger one's 300 feet. So the 300 feet goes down here, and we put X for the smaller. Now, because I had the areas smaller to larger, I do the same with over here, smaller to larger. Cross multiply, and you get 25X equal to 9 times 300. Solve that for X, and we get X is 108. So it's 108 feet squared. So just knowing the ratio of the areas, we can find the area of the smaller one. So this is the summary of what we have, is if the scale factor is A to B, then the ratio of the perimeters is A to B, but the ratio of the areas is A squared to B squared. And I bet you could figure out what the ratio of the volumes would be. Let's go to the next page and look at number 9. The trapezoids at the right are similar. The ratio of the lengths of the corresponding sides, 6 to 9 or 2 to 3. What is the ratio, that is smaller to larger, of the perimeters? Notice we don't know anything else, any other sides, only these two sides, which gives us the scale factor. But knowing that, we can get that the ratio of the perimeters will be the exact same, 2/3. And we know that the ratio of the areas will be that squared. So 4/9. It is that easy. The area of the smaller pentagon is about 27.5 centimeters squared. What's the best approximation for the area of the larger? Well, what I have here with these two pentagons is I can get the ratio of the sides. So 4 to 10 will give me my scale factor, which is 2/5. So that's my scale factor. I know that the ratio of the areas will be 2 squared over 5 squared, which is 4 to 25. So if I do 4 is to 25 as, and it says the area of the smaller one is 27, so I got to put 27.5 up here over x. Then I cross multiply. 4x equals 687.5. X is 171.875. So we got about 171.8 centimeters squared. Cross multiply. The scale factor of two similar parallelograms is 3 to 4. The area of the larger parallelogram is 96. What is the area of the smaller? Press pause. Try this on your own and press play when you have finished. All right, so we've got 3 to 4. So if I square that, my ratio of areas is 9 to 16. So I say 9 is to 16 as x is to 96. 96 is on the bottom because the larger one is 96. Cross multiply and solve, and I get 16x equals 864. X is 54 inches squared. Triangles at the right are similar. What is the scale factor? So I've got the areas. Ratio of the areas is 50 over 98. Now what you could do is simplify these roots. I don't know if you are able to or remember how to do that. Square root of 50, I can take 25 out. 25 times 2. Square root of 25 is 5. So this becomes 5 root 2. And 98, believe it or not, 49 goes into. So a 7 comes out, 7 root 2, and these cancel, and I get 5/7. You could also use your calculator to reduce these using the y equals and do a over b fraction. So we get 5/7. So the scale factor is 5/7. The ratio of perimeter, 5/7. And that's all for this lesson. Thanks for watching.